bingo, like an integral bingo
I would be
tomorrow.
completely fine with that.
Okay. It's gonna be an interesting take on bingo. I found this idea and I was like, oh, I like it.
Just don't like, as long as it's not like the ones where you actually have to write out work for it, then that will be a little bit more important.
Where you have to write. So like it works like this. You have to have you will be solving other classmates' problems and they solve yours. You have to get everybody to solve something. And then the bingo part is I'll pull everybody's name from a hat one at a time. And whoever like solved that problem, if they got it right, you cross their name off and then whoever gets bingo. Does that sound?
Wait,
No, I can do a question by myself.
I'll explain it more tomorrow, but that's like the general idea. But we'll see. And then we might have to, I was thinking we could do that. I don't think that'll take the whole time. I think it might be, well, it might, but we'll see. Oh yeah, come on up and grab one. They're hanging out in the calc bin. Okay, I'm going to screen record.
That is very purple. Yeah, it's blueberry. I don't know. Yeah, Andrew.
All right, ready to do some trig integrals. Okay, let me help orient you guys to what these are. So if you, and remember, we're thinking it's the antiderivative, right? What did I have to take? What function will I have to take the derivative of to get that? So if I want to know what's the antiderivative or the integral of cosine of x, I ask myself, what would I have to take the derivative of to get cosine? Sine. So the derivative of sine is cosine, right? So it's sine of x plus c. That constant, because the derivative of constants is always 0, can be whatever. The integral of sine, be careful of this, is going to be negative cosine, because I asked myself, what did I have to take the derivative of in order to get that? Well, what's the derivative of cosine? Do you remember derivative of cosine? Is negative sine x. So if I want to get a positive sine, I would have had to take the derivative of negative cosine. That's a negative sine, which is a sine x. Does that make sense? So it'd be negative cosine x plus c. The other ones are formula. We know the derivative of tangent is secant squared, so the integral of secant squared is tangent squared plus c. These ones we didn't use as often, but cosecant, cotangent is going to be negative cosecant. Secant, tangent, secant. We did use this one quite a bit. And then derivative of cosecant squared is going to be negative cotangent squared. Okay, they're just your reverse derivatives. So let's go ahead and get some practice in. Okay, so here's the goal. I want you to, like, you won't be able to integrate sometimes immediately. So the goal is to get it to a spot where you can.
Your number one's different than our number.
Yeah, the goal is to get it to a spot where you can use the integration formula. So first off, change your number one to what I have, because I accidentally put the homework question in there this time around. So make it 8. Well, it's similar to the homework question, but yeah, make it 8 cos. You can turn a 3 into an 8, and then pop in a 1. Yeah, I made it really easy. Okay. All right. Okay, so the integral of 8 cosine. Remember, we can take any constant out. It's 8 times the integral of cosine x dx plus 21 times the integral. 21 times the integral of sine x dx. Okay, so this one is pretty straightforward. What is the integral? I can look at my formula sheet. And hey, is this on your formula sheet? Yeah, it is. Look at your formula sheet. All these integrals. You have all your trig integrals there. Familiarize yourself with your formula sheet. In fact, you might want to have it out right now so that you are seeing it on there. Whatever you test with, practice with. I always say that. So the integral of cosine is sine. So, right, because you can check yourself by taking its derivative. So it's going to be 8, whoops, I didn't mean to highlight that. 8 times the sine of x. And then plus 21 times the integral of sine x is negative cosine x. And then because this is an indefinite integral, meaning there's no like numbers at the bottom and top here, we will say plus c. Okay. Clean it up a little bit. I would put that negative sign in front. 8 sine x minus 21 cosine x plus c. And this represents your original function, f of x. Okay. Questions there? Okay, look at number 2. Oh no, it's a theta. Okay, remember the differential here, the d theta tells you what variable you are integrating. So I'm integrating with respect to theta. So I can write this as, you can take the integral of theta squared d theta plus the integral of secant squared theta d theta. Do you guys know what the integral of theta squared is?
3 theta. 3
So
theta.
to the, you treat it like an x, right? So if it were like x squared, it'd be x cubed over 3, right? It's to the n plus 1 over n plus 1.
You don't bring it.
So it's theta to the third over 3. Yeah, that's it. Treat it like an x. Okay, then what's the integral of secant squared?
And
Tangent. And then theta, right? It says tangent x there, but we're using theta. And then plus c, because it is a, we would say f of theta then, not f of x, is going to be theta cubed over 3. Or you can write that as 1/3 theta cubed. It doesn't really matter. Okay. And are you guys ready for the next one? Okay, take your time. When you're ready, go ahead and look at number 3 and give it a shot.
All right.
Oh, sorry, still see people writing. Yep, go ahead, take your time.
Okay.
When you're ready, look at number 3 and see what you have to do first.
All right, I can do this. Maybe not. So it's like that.
You guys think you know your first step?
Now.
Let me see if anybody got it.
Well, this can become like.
I said yesterday, if we can do algebra to make the calculus simple, do it. Yeah. Hey, so yeah, did you watch the lesson history?
Yeah, I said.
Okay. So, you wanna find a,
So you just distribute.
yeah, yesterday was a basic intro. This is gonna be really super confusing. But I mean, you can take notes and then like cover the other. The idea is it's like, it's like reverse engineering stuff like derivative. So we're like finding, instead of taking the derivative, we're like looking at the derivative, finding its original function. By using an integral, we call it an integral. It's the same, we also call it antiderivative or similar. Anyways.
That's right.
Hey, so our first step, you guys, I saw some of you got it, is to distribute, right? If we can do some algebra to make it simple, we do. We always want to simplify the calculus we have to do. So this is secant t tangent t minus secant squared of t. And you guys know you still have to have that quantity around the terms times, because dt is with everything, right? It's the integral of all this times dt. Okay, so I can integrate this by parts here. So secant of t tangent t is, do I have a formula for that? Heck yeah, I have it right here. That's going to be secant of t. So this is f of x, your original function. This is what we took the derivative of to get that. And then minus, how about, do I have a formula for secant squared? Heck yeah, it is tangent. So it's gonna be minus the tangent of t. Sorry, don't do x like I almost did.
Plus C.
Plus c, don't forget plus c. And am I done? Am I done?
Wait,
Yes.
question.
Yep.
Yeah.
Go ahead. What's up?
Like, how come you get, like, that should turn into secant plus C, and the other one turns into tan plus C? So do you just get rid of one of the C's?
How do, like, so remember an indefinite integral only has one constant, right? If I say c and then c,
Then make
I could
two
say
C's.
2c, but like really, it's still a c, right? It's still some constant. So I only need to write it once, right? Yep. Yeah. Any other questions? Okay. Okay, I'm curious about how you feel. This is the hardest one. Does anybody have an idea of how to start number 4?
On the bottom,
Yeah.
doesn't that turn into something?
It does. Do we know? Good call, good call. What? Cosine squared, yeah, right? Do you recognize that's a trig identity?
Yeah.
Oh, yeah, look at, now it's on your formula sheet as, you'll see on your formula sheet.
No, I can't do this.
I'm gonna hold this up
Nah, this is too.
right here. Sine squared plus cosine squared x is equal to 1. So if I solve this for 1 minus sine squared, I would solve it for cosine squared is 1 minus sine squared. So I can actually simplify this by plugging in a cosine squared for 1 minus sine squared. So this then becomes the integral of sine of x over cosine squared x dx. Okay, now what? Do I have a formula for that? No.
But doesn't that, no, it doesn't turn into a tangent, because right, there's a square.
Well, yeah, but how could I split it up maybe to get a tangent? We're thinking right.
Or pull out a cosine x from the denominator.
Yeah, so I can couldn't I write this as sine x over cosine x times what? 1 over cosine x dx. Okay. So then that changes to what?
The one on the right,
So the,
tan x times. cosecant.
yeah, so this is sine over cosine is tangent. Careful, what's 1 over cosine? It's secant. So it's tangent x secant x dx. Do I have a formula for that?
Yeah.
I certainly do. It's going to be right. Where is
The second
integral of,
integral.
yep, there it is. Whoop, there it is. That's going to be, the integral of that is secant. So I would say the original function we took the derivative of to get this was secant x plus c, right? Don't forget your plus c. Boom. That's it.
What's
That's
the-
today's lesson.
What's the d of x? Like, what's
What?
one of the dx at the very end?
What's the dx? So that's a, remember that visual I gave you the other day when it had like the area under the curve and it showed you like these little lines and you know what I mean? Like it showed those like distances here. We could approximate the distance and each of these, it's dx is a really, really small value. So calculus is all actually, I think they used Newton called it infinitesimals, right? So infinitesimals. So it's just about really, really small values, like infinitely small values. So dx is, that's kind of what dx represents. Does that help? Yeah. Okay. So task today. Nope, we're in chapter 4 now. Sorry. 4.1 worksheet 2. Give it a shot. I put the trig stuff first and then just more like integral practice below. Okay. Okay, so then my question is, where does my screen recording go?
That's all.